This is paper 3, video 6 for the February mock. The first topic we're going to look at is quadratic sequences and finding the nth term of them. Now we've got two examples here. We're going to use the exact same method for both. The final goal is that we're going to have some form of nth term where we've got an n squared, n, and a number at the end, where a, b and c are going to be the numbers that we're going to try and find in the process. So the first thing we need to do is, looking at this sequence, we need to work out what it goes up by each time to get from one term to the next. So here, if we look, we've gone up by 4, then 8, then 12, then 16. This is the bit that tells us it's not a linear sequence because it's going up by a different amount each time. So then our next step is we actually find out what the differences are going up by. Well, here from 4 up to 8, we go up by 4, 8 to 12, and 12 to 16, all going up by 4. Because this goes up by the same amount each time, this is what's telling us that it's a quadratic sequence. So it's somehow linked to n squared. In order to work out how many n squared we need, there's a little trick that we can use. This is what I would refer to as the second difference. So whatever this second difference is, in this case 4, if you half it, and this is the same thing, we do half of it every time, it gives us 2. Now what that tells us is that this sequence is somehow linked to 2 lots of n squared, or 2n squared. So my next step that I need to do, I actually need a little bit more space and I need the sequence. So I'm just going to rewrite the sequence again so I've got it a little bit easier for me to be able to see and work with it. So if I just write out the sequence again, underneath, because I need 2n squared, what a lot of people do to try and make this easier, it does involve an extra line of working but does normally help, is I'm going to write out the squared numbers to start off with, because I know it's something to do with the squared numbers. So squared numbers, remember, 1 squared is 1, 2 squared 4, 3 squared is 9, 4 squared 16, and obviously 5 squared 25. We worked out from this little bit earlier that we actually need to do 2n squared. That just means 2 lots of these squared numbers. So the next line down I'm going to do is that 2n squared. 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18, 16 times 2 is 32, and 25 times 2 is 50. Now I don't need this little n squared line at this point, so I'm just going to get rid of it so I don't get confused with it. My next step is to look at this line here, this 2n squared line, and think, what do I need to do to each of these numbers to change it into the sequence? So here, 2 to get to 3, I'd have to add 1. To get from 8 to 7, I would minus 1. From 18 to 15, minus 3. From 32 to 27, it's going to be minus 5. And to get from 50 to 43, I'd have to minus 7. Now what we've created here is another little linear sequence, something that you normally would see quite early on in the paper. So if I tried to work out the nth term of this little linear sequence, that I'm then going to combine with the 2n squared to give me the nth term of the quadratic sequence. So here, because it's going down by 2 each time, that tells me that this line here would be minus 2n. And then using the cheat that I think we've used on other videos, I would think what number would need to go there if I went one back in this little sequence, if I treated that as a linear sequence. Well, that would be plus 3. So plus 3. So what I need to do is combine the 2n squared with this newly found minus 2n plus 3 to give us that the nth term of the quadratic sequence we started with is 2n squared minus 2n plus 3. I'm going to do the second one as well. Same idea to start off with. So here we've got 5, 13, 29, 53 and 85. So first step, I need to know what it goes up by each time. So in this case, from 5 to 13 is 8, 13 to 29 is 16, add on 24, and from 53 to 85, that would be add 32. This is not the same number all the way along, but there seems to be a little pattern between these. So to get from one number to the next on this bit, we are adding 8 each time. Now what this tells us, because it's the second difference, is the same number all the way along. It's a quadratic sequence, and actually it tells us one extra thing. If I take whatever the second difference is, so 8, if I half it, which is 4, that tells me that this sequence is linked to 4n squared. It's at this point, even if you can't do any further, you are now starting to get some points in the exam. So if I now do the same as I did before and just write the sequence again, so I've got a bit of clear space to work through the next part. Because I need 4n squared, I know that the sequence is linked to 4n squared. First line I'm going to write down is n squared, so the squared numbers. So again, it's the same as before, 1, 4, 9, 16 and 25. We need 4n squared, so 4 lots of the n squared row. 1 times 4 is 4, 4 times 4 is 16, and so on, just timesing each of these numbers by 4 each time. What I then need to do is work out what am I doing to each of these numbers on the bottom line to get back up to the sequence that we started with. So to get from 4 to 5, I'd have to add 1. To get from 16 to 13, I'd have to take away 3. 36 to 29, I'm taking 7. From 64 to 53, that's minus 11. And to get from 100 to 85, I'd have to take 15 away. Now this has just created another little linear sequence. So if I'd just given this question earlier on in the paper and been told to find the nth term, that's exactly what I'm going to do here. So it's going down by 4 each time. So it is minus 4n. And if we use the little trick of what number would go just in front if I went one back in the sequence, well that there would be 5. So this is an nth term, is minus 4n plus 5. This is the nth term for the linear section. So if I combine it then with the quadratic bit, the nth term for the entire sequence is 4n squared, take away 4n plus 5. Now it is quite a long question. You are going to be getting marks at every stage during it. So if you get stuck, keep working. The method should get you some marks as well. The next little topic we're going to look at is this. So here we have got some sketches of some quadratic equations, or quadratic graphs should I say. Now those quadratic graphs have 2 points shown on each one. I'm going to ignore the first one because the numbers are a little bit trickier on that one, and I think it's probably better to focus in on the numbers when they're a little bit easier. No hint there, of course. So if we start with this one, we've got that it crosses through the point 0, minus 3, so that's this point just here on the graph, and also the coordinate 1, 0. Now it tells us in the question that all of the quadratic graphs here are in the form y equals x squared plus bx, where we're not sure what b is, hopefully we're going to find it, plus c. Again, hopefully we're going to find out what that c is. So in order to do that, what we do, if we take that equation, so y equals x squared plus bx plus c, all I'm going to do is substitute in both of these points, one at a time, and it should show us what b and c need to be. So for this first one, I would advise start with this one. Start with the one where it gives you x being 0. It will work the other way, but it actually creates a little bit more work further on. So if we start with 0 minus 3, that tells me that x is 0 and y is minus 3. So substituting that into here, y is minus 3. If x is 0, 0 squared, that'll be 0 in a minute. B times x, so in other words b times nothing, plus c. So neatening this up a bit, we get that minus 3 equals 0 squared is nothing, b times 0 is nothing, plus c. So just c. So here we have found the first of our values. C is equal to minus 3. So what I'm going to do before I move on to the next one is I'm actually just going to rewrite that little equation here again. So y equals x squared plus bx. But because I now know that c is minus 3, I'm replacing this little plus c at the end with minus 3. I'm now going to do the same thing, but this time substitute the coordinate 1, 0 into this equation. So again, on this time, x is 1 and y is 0. So substituting this in to this equation, y is 0, x squared, so that will need to be 1 squared, plus bx, so b times 1, and it says minus 3, so I just put minus 3. So at that point, get that 0 is equal to 1 squared is 1, b times 1 is just b, take away 3, minus 3. Now neatening this up a little bit, we get that 0 is equal to b, 1 take away 3 is minus 2. So we've got that b take away 2 is nothing. Well, in that scenario, we are going to have that b equals 2. So now we've actually found what b and c are both equal to. So I can write the full equation for this graph as y equals x squared plus, it was bx, we know that b is 2, so 2x. C we know is minus 3, so minus 3. I'll do the same with the other equation as well, just so you've got a second example. So again, we get y equals x squared plus bx plus c. This time, as before, I'm going to start with the 0 minus 40. It's just easier to start with this one, with the x being 0, because it quickly finds out what the c is. So if we start with this one, this example, x is 0, y is minus 40. So putting that into this little equation, y is minus 40, x is 0, so 0 squared, plus b times x, or b times nothing, plus c. So we get here that minus 40 is equal to 0 squared, that's nothing, b times 0, that's nothing, c, so let's write c. So we've got that c is equal to minus 40. So I'm going to rewrite that equation again and replace the letter c with minus 40. So x squared plus bx and minus 40 instead of c. I'm now going to do the same process, but this time substituting 50 in to this equation. So x here is going to be 5, y is going to be 0. So if we do this, y is 0, x squared, that gives us 25, plus bx, so that's going to be 5b, minus 40. If we neaten this up a little bit, we get that 5b, 25 minus 40 is minus 15. So trying to find out what the value of b would be, we would have to add 15 to both sides. So I'm going to get that 15 equals 5b. Dividing both bits by 5 gives us that b must be 3. So to finish this off, I'm just going to rewrite the original equation, but now that I know what b and c are, I'm going to replace them. So we get that y is equal to x squared, b is 3, so I'm going to put 3x instead of bx. And then c is minus 40, so minus 40 at the end.